Welcome to today's webinar, How Big Data and Machine Learning Are Transforming ITSM. My name is John Prestridge, and I'm Vice President of Marketing and Product Strategy at SunView Software, and we're the host of today's webinar. Co-presenting with me today is Lawrence Hall, Distinguished University Professor of Computer Science and Engineering at University of South Florida. He's authored over 190 publications in journals, conferences, and books. Lawrence has received funding from the National Institute of Health, NASA, DOE, National Science Foundation, and others. His research interests lie in distributed machine learning, extreme data mining, bioinformatics, pattern recognition, and integrating AI into image processing. Our goal today is to have everyone leave with some actionable insights around big data and machine learning and a better understanding of how it can be used to transform your ITSM. Before we get started, we've got some housekeeping. Oops. Okay, sorry about that. The housekeeping. This webinar will be available shortly after its conclusion today on BrightTalk. Feel free to share the webinars with others, and check out the supplemental resource kit for machine learning that we put on the BrightTalk website. If you have questions regarding anything that is covered during this webinar, use the BrightTalk Ask a Question window to submit your question to the webinar panel. At the conclusion of our presentation, we'll be answering as many questions as we can that time allows. If we don't get to your questions, we'll do our best to answer those questions and get those out to the viewers of today's webinar. Quickly, the agenda. So it's real simple. Lawrence, or Larry as I call him, will be covering an overview of big data and machine learning, and then I will do the second part of the presentation around big data and machine learning for ITSM specifically, and then we'll hope to have plenty of time at the end to answer any questions that you may have. So let's get started. So what are some of the key drivers around adoption of machine learning? I know that everyone out there probably has read tons of articles in the last 3 months, especially around AI, machine learning, bots. There's a lot going around. Well, this is a chart that Gartner has that really talks about what's really making it achievable today. 4 things that they point to. Increased compute power, so the computing power is there to support it. There's advanced algorithms available to do the science behind machine learning. The tools are available to use to do this analysis, and there really is an information explosion, not only in businesses but across the whole internet, of information that we can use to drive machine learning activities. I'm excited to have Larry here today to present an overview of big data and machine learning. I know he's just getting back from China where he was presenting on these very topics, and we're excited to have him present and share his insights. Here you go, Larry.
John, thank you very much. And we'll go on to the first slide, which is really about big data, and it's attempt to answer what big data is, right? There are different definitions. I think this is a common definition. It's data that has a lot of records, so it's got volume, so you've got a lot of data, right? It has variety, perhaps, lots of different kinds of data, so it's not all uniform data. Like if you think about medical data, you might have images, you might have text records, you might have voice records, so there's different kinds of data. There's velocity, it's changing fast. If you think about tweets, there's velocity there, something's hot and trending and there's a lot of follow-ons there and then it changes. But what can you pull out of that? That's an interesting question. And there could be a combination of the 3 V's. You might have volume, you might have variety, you might have velocity, or just some subset of those. When you have big data, it seems like, okay, now I just need to analyze it. But actually, the first step is really curating the data. Storing it can be an issue, too. And sometimes the data is too big to store. You'd have to treat it as a stream and process it as it goes by. But what I mean by curating is meaning make sure the data is what you expect, that it doesn't have lots of missing values, that it is in the format that is expected, and that you have it categorized correctly. And that is actually, of course, a big part of the problem. When I'm talking to my students, I always tell them to really know your data. If you know your data, you can do something with your data. You don't know it, problem. So what are examples of big data? There are lots of examples, but one nice one is the Friends Network in Facebook, and I think that Facebook can't share that anymore, but there is versions of a Friends Network in Facebook that have been used for research and have all the connections. It's a big kind of graph theory problem. It's very interesting. Amazon's history of purchases, right? Amazon's trying to sell everything to everybody. They have a big history of purchases. From the history of purchases, they can tell what you'd like to buy, perhaps, even if you didn't know you'd like to buy it. Records of cell phone calls, texts, tweets. So texts can be very interesting because they can tell a story about something that's happening that you don't know. If everybody's texting here in Tampa on I-75 that traffic is bad, well, there's probably a wreck on I-75, and the police could come out and go try to find that wreck even before the people call in. You might have service requests in your company, right? And that can be the history of those can help you optimize how that's handled, and you may know who's an expert at handling one type of service request because they always handle it and get it done twice as fast as when it doesn't go to them. So these are all nice examples of things that you can hold and use. If you think about image posts and shares on Facebook, right, those things have a lot of velocity because people are posting all the time. And the posting happens at night, right? So when I was in China, if I wanted to look at Facebook, which is an issue, but that's a different story. But my evening was morning here in the U.S., so there wouldn't be so many posts, but there would be from the day before. We know that evening is when there are more posts. And we also know that pictures that get put onto Facebook and get shared can get posted multiple times, which is fine if you're wanting to look at pictures of cute cats, for example, but it isn't so great for Facebook, which now may have 1 million stored images of the same cat, and that's taking up a fair amount of space. A lot of us use Netflix, and I do that, and they have your ratings of movies and shows, and they use that to suggest other things you might like. In fact, they had a $1 million contest a few years ago to improve their ratings, and it was won using machine learning and using an ensemble of machine learning approaches, and it made the significantly better. Made it significantly better. All right. So, what do you want to know from big data? Well, if you're using Amazon and you're using it to buy books, I use Kindle books, they'll suggest things that I might like to buy, and it can make really good suggestions. It does that by looking at what other people who bought books that you did bought and saying, well, they seem to buy the same kinds of things you did. They bought these, you didn't buy them. Maybe you'd like to buy those, and it can be pretty good. I do mountain biking, right? So if I bought mountain biking gloves or biking gloves, I might get a suggestion that I would want a pump for my bike, or I might get a suggestion that I would want tubes for my tires, except I run tubeless tires, so too bad for you, Amazon. But they do it pretty well. I mean, they can't know that I run tubeless tires. So they do that with a particular way of a variation of association rule learning, which is something that other than that sentence, you won't hear again today. Next slide. All right, so what is machine learning? So machine learning is an original term for taking data and turning it into rules or some sort of predictive. It could be a numeric prediction, or it could be simply a classification. Data mining is a little bit later term, which means the same kind of thing, except it's more focused on having lots of data. Machine learning is more focused on the theory. It could be small data, big data. And then predictive analytics is what people sometimes say today so they can get funding, and it sounds different than machine learning and data mining, but it's really the same kind of thing. And so they can be used interchangeably, although there are subtleties to the different names. What you often want to do is if you want to label something, put it into a class, you need to have class labels, right? So somebody has to give you those class labels, and then a machine learning algorithm can build a predictive model. Now, getting class labels is not easy because the people who are good at labeling stuff are experts. And if they're experts, they don't have lots of time to just go ahead and label stuff. But you will have some data that's already labeled because you've stored it in some ways. You can help ask experts for just a few important examples. There are ways to do that through semi-supervised learning or active learning. And if you think about Amazon, that's got lots of users and lots of products, and it can aggregate what people bought together. I mentioned this before, and suggest what you might like to buy. It does such a good job with books sometimes that some of you may remember that Senator McCain complained that Amazon had too much information about him because it was suggesting books to him that he wanted to buy. And how did they know that? But they didn't really have any information per se about his personal life. They simply knew what he liked, what other people who read the same kind of books he liked read, and that's what it was suggesting. So are all the cats the same? It's a great title. And if you're looking at the slide, you see the cute picture of a kitty meowing. If we can recognize the images that are the same, then we can just store one image and link to it. This is an issue, for Google, for Facebook, and in fact, there's some pretty good algorithms now from deep learning that are really good at recognizing images, especially if they're fairly simple camera images. And so they can do a pretty good job of grouping things together that are the same. And you can do this idea of just linking one time and save, for one cat you may save, say, a gigabyte, but if you have 1,000 users doing different kinds of things with different kinds of animals and pictures, that begins to add up pretty quickly. So what about machine learning and data mining algorithms? There are lots and lots of algorithms out there, and if I don't touch on your favorite ones, sorry for that. But I'm going to touch on some that I think are widely usable, widely used, and important. And the first one is decision tree algorithms. Why decision tree algorithm? Old algorithm, pretty simple. I'm going to show you an example of it. But the reason is that if you have a lot of big data, they're really fast to build. They're reasonably accurate. So if you have labeled big data and you want to know how well you can predict, build a decision tree. It won't be the best you can do, but if it's 40% accuracy, then you're never going to get to 90 if that's where you need to be. If it's 85% accuracy, then you might, with a more sophisticated technique, get to 90%. And if you're going to use decision trees, use random forests, which is an ensemble, multiple classifiers. It gives you better accuracy with the wisdom of crowds approach. Each predictor is imperfect, but the sum of them is good. And wisdom of crowds, some of you may have heard about this kind of idea, but a simple example is if you go to the county fair, and the county fair has a hog that's going to be slaughtered, and everybody can put in a prediction of how much that slaughtered hog will weigh after it's been slaughtered. So that means I can do it, and I have no idea. And lots of farmers can do it who have an idea. Well, it turns out that after it's all done, they're less than a pound off when they average the predictions, which is pretty startling to me. Now, if you have big labeled image data, right? Convolutional neural networks have been really, really good recently. They use what's called deep learning. So there are multiple hidden layer neural networks, and the convolution part is generating some features up front. Does anybody fully understand how this works? I don't think so, but it is very good at recognizing images. There's a big ImageNet set of images with 1,000 classes and 14 million stored images now. And they have a contest. They haven't done a contest with the 14 million, I don't believe. I think 4 million may be the most. But the convolutional neural networks beat everything at doing the recognition. And they're not 99% accurate, but they are pretty good. Support vector machines are another one. They let you project data into a higher dimensional space and then do a linear separation. Why is that important? Because if I have a nonlinear problem, like I'm trying to get two S's next to one another, they're two classes, I need to separate that. I can't do it with a line, perhaps. But I can do it by projecting it into a different space and separating with a support vector machine. If you don't have any labels, but you want to group the data, K-means or fuzzy C-means clustering allows you to group it. You have to try to figure out how many groups there are, but once you figure out the groups, figure out the number, you can get some nice results, and there are algorithms that tell you what the number should be from the data. All right, so I'm going to give you a little example. So when you walk away from here, you'll have a little example of how a decision tree works. We have to have features when we have data. And this is an example I use in my data mining class, the first kind of example. And it's an example, let's say, to play tennis, and we have some historical data. And we're going to try to figure out whether on any given day we're going to play or not. And if we go to the next slide, I'll show you what the data looks like and talk it through a little bit. All right, so this is the weather attributes. So we're here in Florida, and if the outlook is sunny and the temperature's hot and the humidity's high, that it doesn't matter whether it's windy or not, we're not playing. It's hot and it's humid, and that's all summer. So that probably is not a Florida prediction kind of thing, because you just can't play in the summer. But you get the idea. The outlooks can be sunny, overcast, rainy, and the temperature can be hot, mild, cool. The humidity can be high or normal, and the wind is either true or false. In this case, you might say, well, why don't you give me the miles per hour in wind? Sure, can do that. Why don't you give me the degrees in temperature? Sure, we can do that. But this makes my example simpler, and I'm giving you categorical data. Okay. All right, so taking that data and then just looking at the outlook attribute. So you can call it an attribute or a feature. It's the same kind of thing. I use them obviously interchangeably. I said features before. I've got attribute here. So with the outlook, we have three possible rules. Sunny implies no, and that makes only one error. So it's almost always correct. Rainy, yes, makes two errors. Overcast, yes, doesn't make any error and covers 4 examples. So the 0 means no errors, and the coverage is 4 examples. But out of the examples I have here, you can see that we get only 3 errors out of this. And you know, if you're looking at it, you can quickly look and see sunny no for the first 2, and then as you go down, sunny no for the next one, sunny yes for the one after that, sunny no for the one after that, and that's it. So we've gone through and we've got the one off, and the rest were no. All right, so I can do the same thing for all of these attributes, right, for temp and for humidity and for windy. I'm enumerating the values that we have. Now, this is, of course, a very unsophisticated approach to doing it. I'm just looking at how many errors we make across the branches of the tree when we do it. And in a decision tree, you'll typically use information gain to make the final decision. You'll do this kind of split, but you'll take the information gain to decide which one to take. In this case, the information gain and the one I'm going to point out are going to be equivalent, but you can also use the Gini measure and for deciding which one. And there are other measures. There are some old statistical measures that statisticians have recently put into packages, and they're very good. They're a bit more complex, but there are lots of possibilities. So you have all these, and if we look at them, you see the total errors for Outlook is the fewest, 3 out of 14. The next best is humidity, and the next best is windy. So because that's the best one, that's the test we would put at the top of the tree. The next slide shows the tree with this test. All right, so now we have Outlook, and you can see overcast When it's overcast, there's 3 yes examples. When it's rainy, there are 3 yes examples and 2 no examples. So we need to do something about rainy. When it's sunny, I have the table there so we can try to take a look and decide what would be the next test, or should we, and sometimes your stopping criteria is there's only 1 error at a leaf, but for this example, we want pure leaves, no errors at our leaves. So you can see that if we look at humidity, I have high for no, is no, high no for the second example, high no for the third example, and high no for the last example, and then normal yes. So that seems like that is a perfect one, right? We've got 4 no's, 1 yes. If we take the humidity high, we get no. Humidity normal, we get yes. That's what we're going to use in the next to do the test. And boom, there it is with humidity, high, normal, perfect split. We didn't do anything about rainy. We would have to now look at the table for those 5 examples and decide what attribute to use. And we have an almost complete tree. The next slide shows the complete tree. So now we have a complete decision tree when windy does a perfect split into true, with true and false, 2 no's for true, 3 yeses for false. And this is now a complete tree. It will it perfectly takes those 14 examples. But of course, the question that we would all ask is, well, how good is it on unseen data? And that is really the important question, and not delved into here. What I wanted just to show is that it's pretty simple to build a decision tree. Why decision trees are good is that, from my perspective, you can take if you have a lot of data, they're fast to build, but they're also fast to classify because you're essentially branching each point, right? So it's going to be some sort of log time to classify. Even with a giant decision tree, even with a giant ensemble of decision trees, you'll get an answer in less than a second, usually on a computer. So if you need real-time decisions, you're good to go. Now, is it the best decision that you can get? Not necessarily. If you're doing images, you would not probably use decision trees, but other kinds of data, it's good. All right, so summing up from what I wanted to say, you have heard a little bit about big data, some types of big data, that it has volume, variety, velocity. And we talked a little about machine learning successes, some of which you knew of but maybe hadn't thought of, like the Amazon recommender system, the Netflix recommender system. Also, when you go to make credit card purchases, there is a machine learned algorithm in the background deciding whether or not to grant you the credit. And you probably didn't know that. Companies have to be a little bit careful because they can get sued in court about whether it's biased against some group, and it's very difficult to tell how it's making the decision. So they sometimes, what they do, I think, is pop anything they're not very sure about to humans to make the decision. And you also know how to build a simple decision tree, I think. So that's it for me, and I go back to John.
Thanks, Larry. That was a great overview of big data and machine learning and the application of the technology to solve some real problems. I think what we see from his examples is big data is here already, and machine learning is a proven technology that's being used in many places, and a lot of the examples are in consumer-oriented technologies like Netflix, Amazon, and Google and others that many of us use every day. So this technology is already proving benefits in those areas, and the real question is, can we take that technology and really transform in the enterprise with IT service management? And that's what we're going to be talking about a little for the rest of the presentation. So I wanted to start out with a Gartner quote that's kind of thought-provoking. By 2018, things as customers will drive 6 billion support requests, requiring businesses to develop new customer support capabilities. That's a big number, and I think this is kind of a thought-provoking thing that Gartner put out. It's really to get organizations thinking about this whole movement to where not only people are going to be submitting service requests, but things are going to be submitting service requests. The evolution of IoT is upon us. You've got smart machines being developed every day. You've got bots evolving in the enterprise. All these will be capable of submitting requests on behalf of a system or a person in the future. And we really need a service management platform that can handle those requests and improve the automation of resolution of some of these. A good example is last year I bought a car, and I was kind of surprised. After driving it a month, I got an email from it, and it basically sent me an email saying, yeah, we've checked everything, and here's all your components, and here's the status they in, here's the service we recommend. It was kind of amazing to think about all the data that the manufacturer of the car is starting to collect, not only about the health of my car, but about my driving characteristics and things like that, I'm sure. So in the future, they'll be able to start selling me cars that would fit my driving profile. So that's just the way the enterprises are moving. It's digital economy and the ability to leverage data in the organization. And I think IT service management is a big part of that. So before we get into the how around machine learning and ITSM, I wanted to talk a little bit about the why. And it's really about supporting this concept called the digital workplace. And that's just a term that's been put on, the enterprise and how we support the new style knowledge worker in the enterprise. We've got a whole new demographic. I think by 2020, 50% of all knowledge workers will be of a millennial type generation. And that just means that they're used to technology. They're used to consumer style technology. They're used to a different type of interface with technology. And they're just going to be more demanding around that. In addition, there's a lot more applications. Another statistic is about 88% of apps that employees access on a daily basis are not even distributed or controlled by the IT organization. So that's a big difference in what our knowledge workers are going to be using. A lot more technology. What we need is technology that is more effective in engaging with those end users, whether it's the IT service staff, IT staff, or even the end users needing support or needing to request things. Like you see on the slide, the volume, velocity, and variety of requests are there. That's kind of what Larry just defined big data. I mean, I think there's going to be an exponential change in the amount of data and the variety of data that service management is going to have to handle in the future as things start submitting requests. Also, the business expects more apps delivered more quickly with consumer-like support. Like I said, we're supporting a whole new generation of knowledge workers that are going to demand different level of support, a different way of support. Our technology needs to be engaging. Our services need to be engaging. And you need to do more with less. We've all heard that. I've been in IT for too many years, and we always know that we're expected to keep up with the business, deliver services at the same time. Budgets don't seem to keep pace with that, so we got to find smarter ways to deliver services in the enterprise. So, if I was summing this up, it would be we need to transition from being reactive to proactive delivery of services that leverages a people-centric approach to empower employee efficiency. That's a mouthful. Let's break it down a little bit. Today our IT service management, our organizations, our workflows, everything seems to be set up around being reactive. So someone has a problem, they report it, we work on it, we fix it. That's reactive. We need to move to being more proactive and understanding what could happen, what's coming, and fix things before they ever become major problems or a dissatisfaction for the end user, so that we can operate more efficiently. Also, a people-centric approach is just about having a layer of a more intelligent interface to the technology that empowers people to move faster. And I think that's really what machine learning is going to do, is it's going to allow us to put in a layer of intelligent features that's going to allow people to move faster, uncover more hidden patterns, predict better what's going to happen. All the things that we see on the consumer side, we should be able to do in our IT service management. I pulled another quote from Gartner, which I think is very relevant for our discussion this afternoon. By 2019, IT service desks utilizing machine learning enhanced technologies will free up to 30% of support capacity. Well, some would say, well, what am I going to do if I don't need capacity? I may lose my job, but that's really not the case. As we talked about before, the volume of requests is going to be exponential. We've had to figure out smarter ways for dealing with that. And I really think machine learning, and I think the analysts think so too, that machine learning enables technologies in IT service management and at the service desk level definitely will help reduce the resources required and allow us to do more with less. So now let's move into the section of the presentation where we're really going to talk about the how. So we talked about why. We really need a more engaging personal experience for not only the IT service desk staff, but the employees of the company. And the IT service management platform is the perfect intersection of people with technology to really transform the organization. So it starts with data, and it can be big data. Sometimes it's not big data, but it's a lot of data, and it's ticket history, all the ticket history you have in your organization, all the knowledge that may be in your organization, assets. It could be interactions of requesters with the service desk, so looking at that information. It also could be usage patterns, so looking at what applications people are using and what time of day they work and what time of month they work the most, and all those things are data that can be pulled into a system for analysis. And this data is not necessarily all structured. It's structured, unstructured. It could include images. It could include a lot of things. And we need to efficiently work with this data and analyze it to uncover things. This may require large-scale data processing environment, and this is just a way of pulling this data in, managing it efficiently, and then exposing it so that machine learning can effectively take advantage of it. One of the statistics I had on the screen there is 90% of data today is machine-generated or people interactions. So there's a lot of data that our machines in the enterprise are putting out through that we see in our monitoring systems. Also, there's a lot of people interaction information, whether it's with the service desk or it could be interactions in the social collaboration platform that we're providing the organization. There's a lot of opportunity in the future to pull from that and to help the service desk organization deliver better services. So the next step, so we got the data, and then really it's about applying the machine learning technologies like Larry was talking about. There's all types of algorithms, and he did a good job of describing some of the more popular ones, but you can do things like regression, anomaly detection, clustering, classification, and tons of them that could be talked about. And it's really about finding the best way to analyze the data to solve the problem that you're trying to solve with the application of that technology in your organization. And you really come out of it with this domain model that you can build things on top of to help the service management organization. And you really could build this, these things could be built in multiple ways. You could build this and really focus in on incident management as an ITIL process that you're going to apply machine learning to and solve. and all the other ITIL processes as well. You could do the same thing. Or you may have some problems that you're solving there where you want to go across all the data or multiple processes. Like you may want to look at incident and problem at the same time and see if you become a better predictor of problems by looking at incidents that are coming in and things like that. So there's multiple ways that you can leverage machine learning in an ITSM environment to really create what we call intelligent features within the application so that the workers can be more efficient. So what do you need to do this? Like Larry said, expert. You need someone that understands the data, maybe a data scientist to help. May need a big data infrastructure to manage the information and the data effectively, machine learning tools, some programmers that can pull us together. That's the traditional approach. And that's why a lot of organizations shy away from doing it in the enterprise, is it requires quite a set of skill sets to pull this all together. What we've done here at SunView Software is we've worked to build out, to solve very specific problems, a solution, a technology that we can provide our customers that has already done the heavy lifting around, the data, the machine learning and the model, and down to creating some intelligent features within our application that takes advantage of those to do things like build recommendation engines, have, intelligent search, predictive analytics, or even build out some bots that can do things based on the information that it pulls from the system. So, this is really our vision of, how we want to take this technology and make it usable by every customer, not by just those that have experts to pull it together. So let's take a look at some of the use cases that we're working on and get a feel for how it really could impact and transform IT service management. So first, let's take a look at recommendation engines. So here's some ideas: is that, take for example a service desk tech comes into the system, opens up a ticket. Well, immediately they could have a recommendation engine that comes up with resolution suggestions that they can pick from, and those suggestions would be based on analyzing, could be millions of tickets if you have a data set that large, or whatever size the historical data set is. It could be looking at all those records and bringing back, based on the resolutions we found for very similar problems, here's some suggested resolutions. It could also curate at the same time knowledge that's available and already put together to solve a very specific problem, and bring that to the tech. So it's adding intelligence at the point of the user's exposure to the technology so that they can move quicker, solve problems faster. We all try to do this intuitively by our own knowledge and experience, but a lot of times people working on a level 1 service desk may not have a lot of experience, and this can help them do their job quicker and more efficiently by having that kind of capability. And another good example is a level 1 ticket completion. So as a level 1 analyst, they get a ticket summary in. The machine learning can already, help predict what all the fields on the form should be. So, and then they can either choose to take the recommended characteristics of that ticket, or they can put in their own. But again, it's guiding them through the process and making them more efficient by leveraging all the existing data that exists. Also, intelligent routing. Tickets come in, and being more intelligent about how you route certain tickets. As Larry talked in his presentation, I heard him mention that you might want to route it to the tech that can solve that problem the fastest. That's exactly a good example, is looking at all the information, not just the ticket parameters, but past history of execution by particular analysts and things like that. Allows the routing to be much more sophisticated and get it to the person that can do it the fastest and most efficiently. All these things point to faster resolutions for the organization and a reduction in resources. This is where that 30% reduction in resources is doing things like this, moving faster and providing that right information at the right time. So intelligent search, a good example, and the examples we got here that we've worked on are really pointed at the end user. So in a self-service environment, you come in and just the knowledge curation. So if I type in a question that I have, being able to curate and pull back based on historical information, recommended knowledge that may help you resolve your own issue. That's an important feature. I know you can do that with simple search, but there's a lot more to it when you apply machine learning technologies to it. You can be much more accurate and provide much more thoughtful knowledge. Also, smart notifications. So if there's say you're having a performance or an outage with a particular application, we build out notification systems in our IT service management platforms that are very structured and based on teams and all those things. But smart notifications really is about notifying the people that we know are interested in that, or we know that you really need that based on their usage. So based on what applications we know they use, based on the data that we collect, being able to only notify the people that really will feel an impact if this system is not available. That's the only way you can do that is by having some kind of sophisticated technology like machine learning that can analyze all that data and help you pull that together. Also contextual search. So when I search for something, give me results that matter to me, that are associated with my behavior, my assets that I have, and things like that. So again, improving that whole self-service experience. Over on the predictive analytics side, a few examples we have there is user sentiment. So looking at the interaction of an end user with the service desk, you can use machine learning technology to start doing things like sentiment analysis and being able to take a look and understand the sentiment of a person that you're corresponding with, and maybe even take action based on, if you see that they're are getting more frustrated, maybe that needs to be promoted to a manager or handed off to a different analyst that may be better suited to handle that particular type ticket. So I think in the future, as we look at supporting these new type knowledge workers, understanding sentiment is an important aspect. Also scoring change risk. So change management, again, the velocity of change in organizations is going to be tremendous as we continue to deliver more and more apps and have to have more and more changes in a more rapid way. Being able to automate the change process is essential. The existing ways of going through a cab where everyone analyzes all the different risk parameters around a change is a little bit too bureaucratic for most organizations today to keep up with the pace of change. So things like machine learning can come in and help with doing a better job scoring risk on a change, and not just looking at the parameters in the ticket itself, but looking at all things like who's going to implement it, what time of month it is, all the things that go into really making an informed decision based on history too, so being able to come up with a more accurate prediction of change risk. And also predicting problems. This is a big one. You see this a lot on the IT operations management side. There's vendors out there that use machine learning to do log analysis and start predicting problems before they can become real problems for the organization. So I think that machine learning is a perfect example of that. And I think looping in human interactions to that is an important aspect. All these things come to better decisions, really predicting and making better decisions for the organization. The last area is bots. There's a lot of chatter out there about chat bots and other kind of bots. It's really about having like a virtual personal assistant that works for you. So an example of some of the things that we're working on is an intelligent autoresponder. So when a person submits a ticket, and it's actually has an autoresponder that takes the ticket in, looks at it, using machine learning technology will curate knowledge, recommended resolution, and send back to the end user, as well as estimated time if this knowledge doesn't fit it doesn't solve their problem, and it estimates the time that a tech will take to complete the task based on the historical information. And then so it just creates a better environment for the end user. Another good example is a self-service virtual assistant, and this is where the bot may live on the workstation that a person uses and may be very familiar with the applications that they use and may see performance degradation or may see a problem and can even submit a request without the end user being involved in the process altogether. These are new and evolving capabilities that will be coming to market, so that we can move faster, engage our users better, and provide them a better experience with technology overall. We're excited about what we've done with the machine learning technology, and first ITSM platform to fully integrate the machine learning technology across our modules. So we're excited about that. So in quick summary, big data is here and machine learning is a proven technology. I think that we all can agree that it really is a matter of how do we take advantage of it, because it's proven technology. We need a proactive delivery of services to support the digital workplace. So we need more engaged technology environment. And I think machine learning, as the last point says, we need to invest in big data, machine learning, and other AI technologies to transform ITSM. I think that there's a lot of proof that if we're looking at saving time in the new digital workplace, that you have to have these technologies integrated into your environment. So again, SunView software, we have ChangeGear, our enterprise ITSM platform. We announced earlier this month that we have the machine learning technology that we've rolled out, and later before the end of the year, we'll be launching ChangeGear with us integrated for our customers. If you want to learn more about this general topic, we've got a Learn URL there on the screen. Feel free to navigate to that. We have some blog articles, a video, and some other information that you can use. So now what we want to do is move to the Q&A section, and me and Larry will be handing off the torch as the questions come in. The first one that we'll cover is one for Larry, and that is the tree algorithm that you discussed the most commonly used?
Decision tree algorithms are very commonly used. There really isn't, I didn't go into enough detail to tell you whether it is the most commonly used kind. I would say that that using information gain in the decision tree to make the splits is probably the most common. And again, it's a really good algorithm for getting a baseline because it's fast and easy to build if you have labeled data, but it may not be the best accuracy overall.
Okay, the next one is for me. Will your ITSM or machine learning work on premises? Yes, our solution will work with our on-premises application and our cloud-based application. So you'd be able to use either. So we don't use cloud-based machine learning algorithms. They're all internal, so we'd be able to deploy that on premises. The next question come in for me was, will I need all the skills you discussed if I use your ITSM? Well, I can't say what all skills you will need. I'll know that we've simplified the process of implementing machine learning with our ITSM platform. We build out certain intelligent features. with our technology that you'll be able to take advantage of. Going forward, we'll have a roadmap of more and more features that we will be implementing that will have an intelligent component to take advantage of that technology. You know, if you want to go beyond that, you may need some additional expertise, but, you know, what we see is, what we expect is a typical, you know, service management experience is what we would be expecting in the organization. The next question I got for Larry is, how do you decide which type of algorithm to use?
It depends on the problem. So if my problem is to do prediction, I have labels, and I go with either decision tree, support vector machine, ensemble of decision trees. If I have to classify images today, I would go with a convolutional neural network, a deep neural network. If I need to predict a number, so if you say, I want you to predict how many requests we're likely to get on Mondays, then I would use a regression classifier, and I would use ridge regression. And if I was trying to predict what, you know, like the Amazon kinds of things where we want to predict what other products you might buy, I use, of course, a recommender system, something that was had some variation of association rules in it, although Amazon does not use, for example, association rules. But again, it's going to be dependent on the problem.
And the last one we'll take today is also for Larry, is what programming languages are used to leverage the machine learning algorithms?
So that's an interesting question. And one package that's used a lot now is the R package, which is also a programming language, and it has a lot of machine learning kinds of things built into it. For deep neural networks, people are building their own kinds of. I mean, Google has a thing has this thing called Tensor, a Tensor kind of language. I believe it's Google. So if I really want to build fast algorithms, of course, I build them in C. That's what I try to get my students to do. They don't like it because it's really lousy on the interface. But if we're building a new algorithm, that's what we do. If we're using old existing ones, like you might be doing, R is a good choice, or a package like Orange, or a package like Weka, which is Java-based. Weka has some issues because it's more of a teaching tool. So maybe R or Orange or 9. A friend of mine developed 9, so I have to give you that caveat. But it's good, good system.
All right, thanks, Larry. Well, that's the end of our presentation today. Thanks again for taking the time out of your day to join us. And the only advice I could give you is that we really need to transform ITSM, and you need to take the time to get out and learn, what machine learning can do for your organization. Have a good day.